Tonight, we're going to explore a truth that shatters our fundamental understanding of cause and effect. For generations, humanity has treated time travel as the ultimate boundary of science fiction. It is the playground of novelists and filmmakers, a concept safely locked away behind the walls of imagination. We are born, we grow old, and we move forward. Time flows like an unyielding river, pulling us in a single irreversible direction from yesterday into today and toward tomorrow. The past is a collection of unchangeable memories, the future is an unwritten horizon. But when quantum physicists peer into the microscopic fabric of reality, the rules that govern our daily lives completely dissolve. Recently, a team of experimental physicists achieved something that borders on the miraculous. By manipulating the delicate, counterintuitive mechanics of quantum entanglement and causality loops, they didn't just simulate a theoretical model. They executed a physical protocol that mathematically and empirically proves time travel, at least at the subatomic scale, is not an engineering impossibility. They demonstrated that an action taken today can fundamentally retroactively alter, manipulate, and rewrite a state that occurred yesterday. To the human brain, this sounds like absolute madness. If you can change the past, you break reality. You invite the grandfather paradox, the idea that if you go back in time and prevent your grandparents from meeting, you erase your own existence, meaning you could never have traveled back in time to change the past in the first place. Yet, the universe does not operate on human logic. The latest quantum experiments reveal that nature has a built-in mechanism that resolves these paradoxes completely, allowing the past to be altered without destroying the present. By the end of tonight, you're going to understand the true, uncompromising mechanics behind this groundbreaking discovery. We are going to break down the physical experiments that proved retrocausality is real, explore how quantum physics cheats the forward flow of time, and look at why the universe's ultimate speed limit might actually be a gateway to the past. Before we dive into the deep dark of the quantum realm, if you love exploring the hidden mechanics of space, time, and existence as much as we do, take a second to like the video and subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Welcome back to Dark Matter Nap. Now settle in, leave your assumptions behind, and let's bend the fabric of time. To understand how modern physics has managed to manipulate the past, we first have to understand what time actually is according to our best cosmological models. Before Albert Einstein arrived in the early 20th century, physics operated under the Newtonian worldview. Sir Isaac Newton viewed time as absolute, universal, and mathematical. In Newton's universe, there was a master clock ticking at the exact same rate for every single object in existence. A second on Earth was a second on Mars, and a second in the deep void between galaxies. Time was an independent stage upon which the universe performed, but Einstein realized that this view was an illusion. He demonstrated that time is not independent, it is deeply interwoven with space, forming a singular four-dimensional fabric known as space-time. Because space and time are linked, the rate at which time passes is entirely relative to your speed through space and the strength of the gravitational field you are sitting in. This is the foundation of time dilation. If you pack yourself into a rocket and travel close to the speed of light, space-time stretches around you. From your perspective inside the ship, your clock ticks normally. Your heart beats normally. But if you look out at a stationary observer on Earth, you will see their world screaming forward at hyperspeed. When you return from your high-speed journey, you will find that while you aged only a few months, decades or centuries have passed on Earth. This form of time travel moving into the future is an absolute, undisputed physical fact. We measure it daily. The atomic clocks on our GPS satellites orbit Earth at high speeds and sit in a weaker gravitational field than we do on the surface. Because of relativity, their clocks tick slightly faster than the clocks on our phones. If engineers didn't artificially adjust the satellite data by a few millionths of a second every single day, your mapping applications would lose accuracy within hours. But moving into the future is easy. It is a one-way street. You are simply accelerating your drift down Newton's river. The real mystery, the holy grail of physics, is whether we can turn the boat around and paddle upstream. Can we step into the past? While Einstein's relativity allows for space-time to warp, it fiercely protects causality on a macroscopic scale. It sets a hard barrier nothing with mass can travel at or exceed the speed of light, ensuring that an effect can never precede its cause. But when we zoom in, past the planets, past the stars, past molecules and atoms, down to the quantum scale, relativity loses its grip. Welcome to the subatomic world, an environment governed by quantum mechanics, where the definitive rules of our reality are replaced by cloud-like probabilities, superpositions and instant correlations. In our daily lives, an object has a fixed location. A coin sitting on a table is either heads or tails. It cannot be both. But in the quantum realm, before a particle is measured or observed, it exists in a state of superposition. A quantum electron can be spinning up and spinning down simultaneously. It exists in a haze of possibilities, occupying multiple states and multiple spatial coordinates at the exact same time. The moment a scientist attempts to measure that particle, a violent transition occurs, the wave function collapses, and the particle randomly locks into a single definitive state. For nearly a century, physicists have debated what triggers this collapse. Does the particle decide its state at the exact millisecond of measurement, or despise this concept, famously dismissing it as spooky action at a distance because it seemed to violate his cosmic speed limit? But decades of rigorous testing have proven that spooky action is an undeniable reality of our universe. And it is this exact spooky action that physicists just use to hack the flow of time. Before we look at the exact experimental setup that unlocked retrocausality, we must confront the massive philosophical and mathematical wall that has historically barred time travel into the past, the grandfather paradox. Imagine you construct a physical time machine, a device that allows a human being to step into a portal and emerge 40 years in the past. You track down your grandfather before he ever met your grandmother, and through some tragic accident or deliberate act, you prevent them from ever interacting. This sets off a catastrophic logical loop. If your grandparents never meet, your parents are never born. If your parents are never born, you never exist. But if you never exist, you could never have grown up, built a time machine, and traveled back to the past to alter your family's history. Therefore, your grandparents do meet, meaning you are born, meaning you do build the machine, and the loop fractures into infinity. Because of this logical contradiction, legendary cosmologist Stephen Hawking proposed the chronology protection conjecture. Hawking argued that the laws of physics must conspiratorially combine to make time travel into the past completely impossible. He suggested that whenever an object attempts to create a closed time-like curve, a path through space-time that loops back on itself, the quantum energy of the vacuum will amplify exponentially, causing a massive surge of radiation that instantly vaporizes the time machine before the loop can close. Hawking famously joked that the best evidence we have that time travel into the past is impossible is that we aren't currently overrun by tourists from the future, but quantum mechanics offers an escape hatch from Hawking's cage. In the subatomic world, information doesn't behave like a solid human being. A particle doesn't need to physically walk down a road to change things. Through a phenomenon known as quantum retrocausality, the universe allows a future measurement to influence a past state without generating a logical paradox. The universe doesn't break, it simply rewrites its internal variables. So, how did physicists actually prove that the past can be manipulated? The breakthrough comes from a series of sophisticated experiments utilizing a protocol known as quantum metrology with retrocausal loops. To understand the experiment, imagine you want to send a gift to a friend. However, before the gift can reach your friend, it must pass through an experimental chamber where it might be exposed to a specific chemical or magnetic shift that alters its characteristics. You want to know whether the gift was altered or not, but you can only examine it after it leaves the chamber. In classical physics, if the gift is corrupted inside the chamber, that damage is locked in. There is absolutely nothing you can do tomorrow to undo what happened inside that room yesterday, but in the quantum experiment, physicists utilized entangled photons, particles of light. They sent a probe photon into an experimental system where it interacted with a hidden variable, an unknown phase shift. This interaction effectively represents the past event. Crucially, before the measurement took place, the researchers introduced a second, entangled helper photon. By performing a highly specialized quantum measurement on this helper photon, after the primary photon had already completed its interaction, the researchers demonstrated that they could retroactively change the primary photon's initial state before it entered the chamber. It is the physical equivalent of looking at a broken vase on the floor today, performing a specific calculation on a separate piece of clay, and causing the vase on the floor to reconstruct itself yesterday, ensuring that it never shattered in the first place. The experimenters demonstrated that by changing the parameters of their measurement in the present, they could filter, select, and dictate which quantum state the particle occupied in the past. They achieved an experimental advantage that is mathematically impossible under a strict forward-flowing arrow of time. They proved that at the foundation of reality, the boundary between before and after is entirely transparent. This incredible modern breakthrough is the realization of a legendary thought experiment proposed decades ago by the visionary physicist John Archibald Wheeler, the delayed choice experiment. Wheeler wanted to push the boundaries of quantum superposition to its absolute logical extreme. He utilized the famous double-slit experiment, where a single photon is fired at a barrier with two parallel slits. When left unobserved, the photon behaves like a wave, passing through both slits simultaneously and creating an interference pattern on a detector screen behind the barrier. If a scientist places a detector at the slits to see which specific opening the photon passes through, the wave behavior vanishes, and the photon behaves like a solid bullet, passing through only one slit. Wheeler asked a radical question: what happens if we wait until after the photon has already passed through the slits before we decide whether to observe it? Imagine a photon emitted by a distant quasar billions of light years away. On its journey to Earth, the light encounters a massive galaxy directly in its path. The gravity of that galaxy warps space-time, acting as a cosmic gravitational lens. The photon must split, taking the left path around the galaxy, the right path, or both, acting as a massive cosmic double slit. This light travels for billions of years before finally striking a telescope on Earth today. Wheeler realized that an astronomer sitting at a telescope tonight can choose to either look at the interference pattern, forcing the photon to have traveled both paths billions of years ago, or deploy a directional detector, forcing the photon to have chosen only one path billions of years ago. The choice made by the astronomer in the year 2026 directly dictates the physical path the photon took at the edge of space billions of years in the past. When physicists finally constructed working laboratory versions of Wheeler's experiment using high-speed optical switches, the results confirmed Wheeler's suspicion. The present choice alters the past reality. Time travel in terms of information configuration is woven into the very mechanics of light. If these quantum experiments prove that actions taken in the present rewrite the states of the past, how does the universe prevent reality from collapsing into a chaotic mess of paradoxes? Why doesn't the subatomic world dissolve under the weight of its own retrocausal loops? The answer lies in a beautiful mathematical framework known as the Novikov self-consistency principle. Formulated by Russian physicist Igor Dmitrievich Novikov in the late 1980s, this principle states that if an event exists that would cause a paradox, the probability of that event occurring is exactly zero. The universe will only allow retrocausal loops that are entirely self-consistent. Let's translate this into the quantum realm. When a scientist alters a past quantum state using an entangled helper photon, they aren't creating a new timeline, nor are they fracturing the existing one. Instead, the mechanics ensures that the past state was always configured to allow the present measurement to take place. The past and the future are locked in a mutual embrace. The future influences the past, but it does so in a way that perfectly sets up the exact future that influenced it. It is a closed, flawless circle of causality. If you traveled back in time to prevent your grandfather from meeting your grandmother, you would find that your very intervention is what accidentally caused them to notice each other in the first place. Your attempt to alter history becomes the engine that fulfills history. In the quantum experiments, this self-consistency is protected by the uncertainty principle. You can manipulate a past quantum state, but you can never extract enough precise information from that past state to create a logical contradiction in the present. The universe allows you to rewrite the code, but it hides the display monitor until the calculation is complete. Reality remains stable because nature forces the past to conform to the future. Chapter 8, The Black Hole Time Machine 70080. While quantum mechanics proves time travel is real for subatomic information, astrophysicists look out at the deep dark of the cosmos to see if the universe has constructed macroscopic time machines, visible celestial structures capable of warping space-time into actual physical loops. And they have found them. They are called Kerr black holes. When a massive star collapses under its own gravity, it creates a singularity. If that star was spinning before its death, which almost all stars do, it forms a rotating black hole, known as a Kerr black hole. A rotating black hole doesn't just pull matter toward it, it drags the very fabric of spacetime around with it like a vortex, a phenomenon known as frame dragging. This creates a highly specialized region outside the event horizon called the ergosphere. Within the ergosphere, spacetime is spinning so violently that it is physically impossible for an object to remain stationary, no matter how powerful its engines are. Space itself is moving faster than light. If you navigate a starship into a precise trajectory through the ergosphere of a sufficiently massive Kerr black hole, the mathematics of general relativity reveals that space and time swap their dimensions. Distance becomes temporal and time becomes spatial. By executing a specific path around the spinning singularity, your ship can enter a closed time-like curve. You are no longer moving through space to reach a destination, you are moving through the calendar. You can theoretically exit the ergosphere before you ever entered it. The black hole acts as a natural, cosmic time machine built by gravity. However, this gateway comes with a lethal catch. The tidal forces of a black hole's gravity are so intense that any physical object attempting this journey would suffer spaghettification, stretched and torn apart atom by atom down to its quantum foundations long before the temporal loop could be completed. The The universe builds time machines, but it executes anyone who tries to ride them if black holes are too destructive to serve as practical gateways to the past. Cosmologists have analyzed alternative, exotic structures in the fabric of the universe that could allow for macroscopic time travel without immediate gravitational destruction. One of the most fascinating solutions comes from the Tor-Benuti universe model. In standard general relativity, we assume the universe is expanding uniformly. But in the 1950s and 60s, physicists Abraham Taube, Ezra Newman, Theodore Unti, and Luis Tamburino discovered a mathematical solution to Einstein's equations where spacetime itself possesses an inherent global rotation. In a Tor-Benuti spacetime, the universe doesn't just expand, it spins like a Vishal cosmic gyroscope. This global rotation creates regions where the temporal coordinate bends completely back on itself. In such a universe, time travel wouldn't require a specialized machine or a dangerous black hole. It would be a natural property of long-distance navigation. If you flew a starship in a sufficiently large circle across the cosmic void, you would simply land in the past of your destination. Another theoretical mechanism involves cosmic strings. Cosmic strings are hypothetical, one-dimensional topological defects formed during the early phases of the Big Bang. They are thinner than an atom, yet they contain immense, concentrated linear mass. A single inch of a cosmic string could weigh more than an entire mountain range. In 1991, physicist J. Richard Gott demonstrated that if you take two infinite cosmic strings and them past each other at ultra-high speeds, their combined gravitational warping deforms space-time so severely that it creates a localized channel of closed time-like curves between them. An explorer navigating a ship around these passing strings would find space-time cracked open, allowing them to loop into yesterday without encountering a destructive singularity. While we have yet to confirm the existence of cosmic strings through observational astronomy, their mathematics remains entirely pristine. The blueprints for reality allow for time travel. The universe simply hides the construction materials in the deep dark. Chapter 10, The Block Universe Illusion 90-100. The physical and mathematical reality of these quantum and relativistic time loops brings us face to face with a profound, mind-bending philosophical realization about the true nature of existence, the block universe. In our daily human experience, we subscribe to a philosophy known as presentism. We believe that only the present moment is real. The past has vanished into non-existence. The future has yet to occur. We feel like we are riding the edge of a moving wave of now. But Einstein's relativity and the success of retrocausal quantum loops completely destroy presentism. They replace it with eternalism. According to eternalism, the past, the present, and the future are all equally real, simultaneously existing within a massive, static, four-dimensional block of space-time. Your birth, your childhood, the exact moment you are watching this video right now, and the ultimate death of our planet are all permanently etched into the cosmic fabric like frames along a film reel. To a higher dimensional observer standing outside our space-time block, the universe does not happen sequentially. It just is. Julius Caesar crossing the Rubicon is happening right now at a specific coordinate. Humans landing on Mars is happening right now at another coordinate. Time travel into the past is not about changing a historical event. It is about navigating to a coordinate that already exists within the block. When the quantum physicists in the laboratory manipulate the state of a photon yesterday, they aren't erasing a piece of time. They are revealing a hidden link that was already built into that specific slice of the block from the very beginning of the cosmos. The arrow of time, our feeling that tomorrow is unwritten, is nothing more than a cognitive illusion generated by our biological brains to process entropy. We are characters drawn inside a static book, falsely believing we are writing the words as we turn the page. If time travel is real at the subatomic scale, and if the past and future coexist permanently within the block universe, we must ask a radical, controversial question: could biological life have evolved to utilize quantum retrocausality? Could the human brain be an organic time entanglement device? For decades, mainstream neuroscience has treated the brain as a purely classical computer, a network of biological wires and chemical synapses processing information in a strict forward sequence. Cause leads to effect, stimulus leads to response. But a growing vanguard of quantum biologists and physicists, including Sir Roger Penrose and Stuart Hameroff, suggest that the classical model is incomplete. They point to microscopic structures inside our neurons called microtubules. Microtubules form the structural skeleton of cells, but their highly ordered, geometric lattice has led researchers to speculate that they are capable of maintaining quantum coherence, isolated states of superposition sheltered from the noisy, warm environment of the body. If quantum processes are actively running inside our brains, then our consciousness is not bound by classical forward time. This introduces a startling potential explanation for phenomena that have long baffled psychologists: intuition, deep premonitions, and the uncanny feeling of déjà vu. What if a premonition isn't a random chemical glitch or a lucky guess? What if it is a literal instance of quantum retrocausality, just like the Helper photon in the laboratory experiment influencing its entangled part? An intense, highly emotional event in your future might generate a quantum ripple that travels backward through the neural networks of your brain, triggering a subtle, unexplainable feeling of unease or recognition hours before the event actually occurs. We might all already be time traveling every single second, our minds subtly entangled with our future selves, steering our decisions through a quiet, subatomic whisper from Trevorrow. This leaves us with a profound, existential realization. The discovery that time travel might be real, that the past can be retroactively influenced, and that the future already exists is not just a spectacular triumph of experimental physics. It is a mirroring reflection of our own fragility and importance within the cosmic architecture. It is easy to find this realization deeply unsettling. The past, present, and future are fixed coordinates within a static block universe. It feels like our free will is a myth. It feels like our choices don't matter, that our struggles are predetermined, and that we are nothing more than helpless passengers riding a pre-recorded track through an uncaring cosmic matrix. But there is an entirely different way to look at it. The fact that the past can be influenced by the present, the fact that quantum information can weave its way across the temporal horizon, means that we are not passive observers in this universe. We are active participants in its configuration. Every single choice you make today, every thought you think, and every action you take isn't just a fleeting moment that vanishes into non-existence. It is a permanent, indelible signature carved into the eternal fabric of space-time. Your life is an unerasable monument built into reality. We live in a unique, beautiful window of cosmic history where the universe has developed the capacity to turn around and analyze its own code. Through our physics, our curiosity, and our instruments, we have managed to peer past the illusion of the forward clock and touch the timeless mechanics that govern existence. We don't need a physical metal machine to claim our place across time. Our minds, our understanding, and our consciousness have already broken through the cage. Thank you for joining me tonight on this massive, late-night deep dive into the mind-bending physics of time loops and retrocausality here on Dark Matter Nap. If this journey challenged the way you look at your calendar, or made you think differently about the nature of your past and future, please take a moment to like this video and subscribe to the channel. Your support helps us continue to create these deep, quiet explorations into the mysteries of existence. The next time you watch a clock tick, remember that the hand isn't moving away from the past. It is simply mapping a coordinate in a vast, beautiful, eternal architecture where everything you have ever loved, and everything you will ever become, is waiting for you forever. Sleep well tonight, knowing that you're a timeless structure in a universe that is still learning how to remember itself. Good night, and may your dreams reach far beyond the uncrossable horizon of tomorrow.